Second part. Zoom this in a little bit, make it easier to see. Here we go. Now, for the first time, we have negative exponents on the top or the bottom, and they're all jumbled up. And so what we're going to have to do here, Shelby, is we're going to have to say, okay, look at them as every single piece is its own separate little part. So here we're going to start with the x's, Shelby, and then we're going to look at this one. It's negative on top, or Sydney. Sorry, you get M&Ms later. Where do they go? Negative on top, Sydney.
I'm just checking out. That goes on the bottom.
Okay, it becomes a positive on the bottom. All right. Y to the third. It's positive, so where does it go? Stays on top. Okay, now here's the first time we've seen this. A negative exponent on the bottom. Take a guess. What do you think, Ryan? If it was negative on top, it went to the bottom. Now it's negative on the bottom. What's your guess? It goes to the top. Excellent. Good guess. So that negative exponent on the bottom now goes to the top. Now we have a positive exponent on the bottom. Where do you think that goes? Stays on the bottom. So what did we just learn? A negative exponent doesn't always go to the bottom? No. It reverses wherever it is. If it's negative in one position, it goes to the other position and becomes positive.
What doesn't always a positive go to the top?
No, because notice this b to the 6. Is it positive? Where is it positive? In the bottom. And our rules of simplification say it's in simplest form when it's written with positive exponents. So, is it written with positive exponents? Yes, so it doesn't move. It stays where it is.
Oh, this is already a fraction.
Correct. Now, a little bit of a trivia thing, Tara. When you write your answer, let's always try to be standard, and let's write alphabetical first. A's before X's, B's before Y's, etc., etc., etc. Notice the A comes before the Y, just alphabetical. The B comes before the X, alphabetical. That's all. All right, here we go. I tried to give lots of little examples that brought in different ideas. Start here. Mr. Spear, go ahead. What do you think? Top or bottom? Bottom. Good. Mr. Sesnoff, the A. Bottom. Up to you, Grace. The C. Top. Nice job. All right. Katie, over to you. The M.
Bottom.
Excellent. And Justin, to you. The N.
Top.
Top. Well done. Does anybody see anything that needs to be fixed, corrected? Drew?
Who's a number?
So what's 2 cubed? 8. Is anything in non-alphabetical order? Are we okay? So C to the 4th, N squared, A to the 5th, M to the 6th. Nice job, all 6 of you. Well done. All right, let's come over here. Haley, your section. 3 to the 0. Stays on top and becomes 1. All right. Kyle, X to the 4th.
Stays on top.
Excellent. Back to you, Hannah. Y to the negative 2. Good. Y to the 2. Brett? K to the negative 1 on the bottom. Top. Well done. And back to you, Luke. M to the negative 6. Top. Well done. Is anything non-alphabetical? So what should that read? K, M to the 6th, X to the 4th. Do I need to put the 1 there? Don't need it. Since there's something there, I don't need it. Over Y squared. Okay?
Wait. Oh, doesn't K to the 1 need to be there?
I'm saying I don't need the 1 in front of this X here.
No.
And I also don't need an exponent on the K. Because we assume it's 1, right? If there's no exponent, it's just 1. So we don't need to write that there. Okay. Down here to example 3. It says evaluate. Remember when we evaluate, what do? Take the number and plug it in using parentheses. Very important to use the parentheses here. But let me give you a little hint. First, write with positive exponents. What I have found from my students in the past is if they do that first, they don't make nearly as many mistakes. So how do I write x to the negative 3 with positive exponents? What do? Where does that x go? To the bottom. What's on top? A 1. Now let's evaluate. What do I stick in for that x? I come up here, and what does it say I'm supposed to do? Plug in a negative 3. Think with me, everyone. Negative 3 times negative 3. 9, right? Times negative 3. Negative 27. All right, so my answer, 1 over negative 27. Do I want you to write your negatives in the bottom? Please don't. So please give me always your answers with the negatives in the top or out front.
Which one do you think it's better to put out front or at the top?
I like it on top because when it's out front, it tends to get buried in with the divisor bar. And sometimes it just looks like a long divisor bar. So I like it up top just because it's clearer. It's not right or wrong. If you can be clear and you want to write it this way, minus 1 over 27, like that, that's fine. But my danger is when you're working a problem out, the tendency is that just gets buried in the whole line. So either way, just be neat. All right. Y to the 0. Simplify first. 1. All right. Evaluate. For any variable, plug in your values. Don't need to because we don't have any variables, so that's your answer. No point in plugging them in. 5x squared y to the negative 2. Where does the 5 go? On top. What about the x? What about the y? On the bottom. Okay, now that it's simplified, now we plug in. What is the x supposed to be replaced by? Negative 3. And what is the y supposed to be replaced by? A 5. All right, so I need to square first, then multiply. So think with me, negative 3 times negative 3 is 9, times 5 is 45. 5 times 5? Now you're not going to leave your answer like that. We know better. Divide them both by what? 5. 9 over 5. No, that is simplified. 9 over 5. Let's not do 1.8. Let's not do 1 and 4 fifths. Let's just leave it as 9 fifths. But no, I need to remember never to leave it in unsimplified form. Always break it down as you do that. All right, last little piece down here. I show you this because sometimes we need to make sure that we're comfortable here. How many zeros here? 3. So that's 1 over 10 cubed. Why cubed? Because how many zeros? 3. How many zeros here? So that's 1 over 10 to the 5th. Now, what does it say? What are the instructions? Write as a power of 10. This isn't written as a power of 10. This is written as 1 over a power of 10. So, a little bit different than what we've done before. Would you agree that 10 to the negative 3 is the same thing as 1 over 10 cubed? Is this written as a power of 10? Okay. So how do I write 1 over 10 to the 5th as a power of 10? 10 to the negative 5. Have you ever seen negative exponents before?
We worked on them once in.
Scientific notation, maybe? You ever seen them for that? Guess what we're building towards? Explaining where scientific notation comes from and kind of the theory behind it. So this is where we get into really small numbers. Yes, Mr. Dutton.
Power of 10 the first number, not the exponent.
Is the power of 10 the first number? This would be the power of 10. 10 to a power. All right, let's do the other one. 10 to the negative 5. You can think of this as 1 over 100,000. But to write it as a decimal, all you need to remember is it has 5 decimal places. So what I do is I go blank, 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 blank. And I plug in 0, 0, 0, 0, 1. Remember, 10 to the negative 5th is 1 over 100,000. We agree? This is tenths, hundreds, thousands, 10,000s, 100,000. So this is 1/100,000th. But the way I remember it is, it has that number of decimal places. So how many decimal places does 10 to the negative 3 have? 1, 2, 3. And what do I plug in? 0, 0, 1. Well, yeah. Because it's 1 over that.
It was a different number, like 22.
Well, that's scientific notation, and we'll get to that later. Right now, it's just 10 to a power. That's what I want to focus on. Okay, a little reminder. What does EOO mean? So this is really 1 comma what? 5, then 9, then
13.
etc., right? That makes sense? So I don't want you to be doing 30 problems here. You're really only doing like 15 problems. How long will these take you? I mean, we just did like 30 problems here as we were working through them.